Right, so Charles's law is the next one, and this is the law relating temperature and volume. So what do you think is going to happen as you heat up a gas? Well, according to what we've already talked about, the gas is going to gain energy, so it's going to move faster, it's going to want to expand, because those particles are going to push more against whatever's holding it. And so as you increase the temperature, the volume is going to increase. Think about if I had you in class, I could do this for you, but you've probably seen this before. If you have a balloon and you blow it up and then put it in liquid nitrogen or something else very cold, it's going to get smaller. If you take a hairdryer to it, it's going to expand. So temperature is going to affect volume. As well, here, this is exactly what I was talking about, except in water. If you put the balloon in cold water, it contracts. The other way, it expands. So this is Charles's law. What this is saying is, what this this mathematical expression means that as you increase one, you increase the other. So you increase temperature, you increase volume. Whereas with Boyle's law, you increase one, the other one decreases. You increase the volume, you're going to be decreasing the pressure, and so on and so forth. So on this one, they go together. They're directly proportional. So you do it the same way. Put your initial conditions on the left with the ones and your final conditions on the right with the twos. This time you just have a little division already set up there. So here you go. A balloon in a room at 24 degrees Celsius has a volume of 4 liters. The balloon is then heated to a temperature of 58 degrees Celsius. What's the new volume? Well, we got the equation V1 T1 equals V2 over T2, like so. Oops, sorry. I'm already messing things up. V2 over T2. I've been away from school for too long. Now, here's the thing. If you remember, you can never put Celsius in. Always has to be in Kelvin. So how do you get Kelvin? You add 273. So you're going to add 273 to both of these, which means you're going to get 297 here. 31, I think, for the other one. Sorry, my brain is not going and on all cylinders these days because I've just been at home. And then you plug in your 4 liters along with this. So you'll have your 297 and 4 liters here. And then you're solving for V2 and you'll put 331 there. So there you go. Now look how they've arranged this because they're solving it. You follow it the same way that I did on the last page. You're going to end up doing the exact same thing. Is it still here? Yeah. So you'll end up multiplying by 331, dividing by 297. So that's what we got here. You should get 4.46 liters. All right, same thing here. Negative 50 degrees Celsius means that you will be at 223 Kelvin. And then you got 5 liters. So these are your initial conditions. This would be 223 Kelvin. And then 100 degrees Celsius would be 373 Kelvin. So you're just going to find the new volume. So V1 is 5 over T1, 223 equals V2 over 373. That's all you gotta do. All right, I'll talk to you at the